today we are going to discuss about how we find a solution of a system of a linear equation by triangularization method, by decomposition method or by factorization method. The name of a decomposition method is a factorization method, decomposition method and triangularization method. Now, first of all we discuss about a theoretical aspect of a LU decomposition method, which is one is a most popular by the name of a decomposition method. Then we discuss when we apply the Doolittle methods, when we apply the Kraut's methods, when we apply the Cholesky's method, and which one is also known as a square root methods. Means our decomposition method mainly popular decomposition method with the Doolittle's methods, Kraut's methods and Cholesky's methods. So, what will happen in a Kraut's method and what will happen in a Cholesky's method and Doolittle method. So, let us start the theoretical aspect of a solution of a system of a linear equation by triangularization method. Now, let us take a system of a linear equation means such as let a11 x1 plus a12 x2 up to a1n xn equal b1. This one is the first linear equation of a system of a linear equation, and suppose second one is a a21 x1 plus a22 x2 up to a2n xn equal v2, and similarly suppose there is a n equation and an1 x1 plus an2 x2 up to ann xn equal bn. Means there is a n unknowns and how many number of equation? N equation. So, here first of all we write a given system of a linear equation into a matrix form of a system of a linear equation. So, what is the matrix form of this system of a linear equation? Matrix form of this system of a linear equation is a what? Here we write the coefficient of a matrix A. Coefficient matrix A, which one is a coefficient of a x1, x2 up to xn. So, here we write matrix form of a system of a linear equation. Matrix form of a system of a linear equation. Matrix form of this system of a linear equation. So, what is the matrix form? This one is a a11, a12 up to a1n, a21, a22 up to a2n. Similarly, an1, an2 up to ann. This one is a value of a. Suppose here we denote the a, and this one is a what? This one is a x. x1, x2 up to xn, and this one equal to b1, v2 up to bn. So, you may also write this one is a matrix A, this one is a matrix X and this one is a matrix V. So, you may also write this one equivalent to what? Ax equal B. Ax equal B. Now, in a decomposition or you may say triangularization or factorization method, the name of these methods are means a decomposition, factorization, triangularization. Here what we will do? We factorize the matrix A into a lower triangular matrix and upper triangular matrix. So, what will happen here? Once we write the given system of a linear equation in a matrix form, means Ax equal B in a form of Ax equal B, then we factorize the A, now we factorize, now decomposed A into a lower triangular matrix and upper triangular matrix. So, here we write A equal L into U, where L is a what? L is a lower triangular matrix, this one is a lower triangular matrix, and U is a upper triangular matrix. Once we factorize the coefficient matrix A into a lower triangular matrix and upper triangular matrix, then we assume that now we write suppose this one is a system of a linear equation 1 and suppose this one is a 2. Now from first, now putting the value of a A from 2 to 1. Then what will happen here? This A become A equal Ax equal V. Then A become what? L into U x equal B. Now again let Ux equal Z. Z is a column vector with how many number of unknowns? There is a n unknowns. Suppose these unknown with the Z1, Z2, Z3 up to Zn. So here you may also write where Z equal a column vector containing Z1, Z2 up to Zn. Z1, Z2 up to Zn. Now, if Ux equals Z, then what will happen? Then, suppose here we write this one is equation number 3. Then if we put the value of a Ux here, Ux equals Z, then this become what? Lz equal B. Lz equal V. Suppose this one is equation number 4. So, in a decomposition method, first of all we solve the Lz equal B. Lz equal B. Once we find the values of a Z, then we solve the Ux equal Z to find out the values of a unknowns. So, what will happen? Steps to solve to find a solution, not a solve, to find solution by decomposition method, decomposition method, what will happen? First step solve Lz equal B. Second step, here we write the second step solve Ux equal Z. So, in a decompose method or triangularization method, first of all we write the given system of a linear equation into a matrix form, then we decompose the coefficient matrix A into a lower triangular matrix and upper triangular matrix. Then putting the value of A equal Lu and again put the Ux equal Z, we find the equation Lz equal B, where Z is a column vector containing the unknown Z1, Z2 up to Zn. So, once we find the values of a Z1, Z2, Zn, then we solve by Ux equal Z, then we able to find out what? Then we able to find out the values of a unknown. Now, question is Here we use the lower triangular matrix and upper triangular matrix, means the values of L and U, means how we find the lower triangular matrix and how we find the upper triangular matrix. So, once we write this one, means A equal LU. Here now we are going to discuss about what will happen in a Doolittle methods and what will happen in a Kraut's method and what will happen in a Cholesky's methods. Once we factorize the, means write A in A equal lower triangular matrix and upper triangular matrix, then what will happen? How many number of unknowns in A? This one is A11, A12 up to A1n. Similarly, A21, A22 up to A2n, and similarly here AN1, AN2 up to ANn. Now, this one equal lower triangular matrix. What is the lower triangular matrix? This one is a L11, 0, 0 up to 0, and this one is a L21, L22, and last one is a LN1, LN2 up to LNn. This one is a lower triangular matrix. Now, what is the upper triangular matrix? Here we write upper triangular matrix U11, U12 up to U1n, U21, U22, not a U22, here we write a what? Here we write a 0 and this one is a 0, here we write a U22 up to U2n, and last one is a UNN. Now, in order to find out the values of elements of a lower triangular matrix and upper triangular matrix, now what will happen? If we multiply the lower triangular matrix by the upper triangular matrix and try to write this one in form of a equation, then how many number of unknowns? So, here how many number of unknowns and how many number of equation? There is a n square plus n unknown, n square plus n unknowns. Why? Because there is a diagonal elements here and diagonal elements here, and if we try to write and we try to combine the L and U, these elements means a diagonal elements, we repeat the diagonal elements once again. So, how many number of unknowns? Here L and U, in L and U there are n square plus n unknowns, and how many number of equation? There is n square equations, n square equation. Then what will happen if there is a n square equation? One equation corresponding to the A11, one equation corresponding to the A12, and last equation corresponding to the ANN. Means we multiply row by column, means we multiply L and U and compare with the left hand side, then we find the n square equation, because in any matrix of n cross n, how many number of elements? There is a n square elements. So, if there is a n square equation and n square plus n unknowns, then what will happen? We unable to find out a unique solution. So, in order to find out a unique solution, we reduce the number of unknowns. Equal to the number of equation, because we know that we able to find out the unique solution if number of unknown equal to the number of equations. So, how we reduce the number of unknowns? How we reduce the number of unknowns? So, in a Doolittle methods, we write what? In order to reduce the number of unknowns, equal to number of equation equal to number of equation and that is equal to n square, what we will do, or you can say the Krauts has put the values of the values of a diagonal element of a upper triangular matrix equal to 1. And in a Doolittle methods, he put the values of a diagonal element of a lower triangular matrix equal to 1. What is the summary? Summary of this one, in order to find out a unique solution for this one, we do what? We do means we try to convert the number of unknowns equal to the number of equation. Here number of equation is n square, number of unknown is n square plus n. So, if we convert the diagonal element of a lower triangular matrix equal to 1 or diagonal element of a upper triangular matrix equal to 1, then what will happen? Then the number of unknown become what? The number of one unknown become from n reduces from n square plus n to n square. So, what will happen in a Doolittle's method? So, in Doolittle's method, we write, we assume that what? We assume that L equal 1 0 0, L to 1 1 0. Similarly, Ln1, Ln2 up to 1. Means diagonal elements, if we concentrate on a diagonal elements in a Doolittle methods, this diagonal elements become 1. So, number of unknown reduces from n square plus n to n square, and u is as usual, u is a u11, u12 up to u1n and 0 0 0. This one is a u22 up to u2n, and last one is a unn. So, now number of unknown become what? Number of unknown become n square. And in our Krauts methods, the Krauts method, what will happen? In a Krauts method, the diagonal element of a upper triangular matrix become what? Become 1. So, in a Krauts method, L become what? L become L11 0 0, L21 L22 up to 0, and last one is a L11 Ln2 up to Lnn. And what will happen in upper triangular matrix? Now, u become what? U become, now diagonal elements become 1 in upper triangular matrix in a Krauts method. So, this one become 1 u12 up to u1n, this one 0 0 0, and here this become 1, and this become u2n, and last one this become 1. This means in a upper triangular matrix, the diagonal elements, this diagonal elements become 1. So, number of unknowns again reduces from n square plus n to n square. Now, number of unknown equal to the number of equation, then be able to find out a unique solution. So, this one is a means a difference between Doolittle methods and Krauts method, and what is the need to convert the diagonal elements equal to 1. Answer is a what? Answer is a to reduce the number of unknowns equal to the number of equation. Now, one another methods under the category of a decompose method is a Cholesky's method. So, later on we discuss about a Cholesky's method. Cholesky's method is only applicable if the matrix is a symmetric matrix and positive definite. So, if the given system of a linear equation, if we write a given system of a linear equation in a matrix form, and if the nature of a matrix A, the nature of a matrix A is a what? Symmetric and positive definite, then we apply the Cholesky's method with some application of a some means the properties of a matrices. Now, we try to solve one numerical example using the Doolittle's methods. So, what will happen in a Doolittle's methods, as we discussed earlier, means in a Doolittle methods we decompose the, first we write the given system of a linear equation in a matrix form. Once we write in a matrix form, then we decompose A into a lower triangular matrix and upper triangular matrix, and in order to find out a unique solution, we write a diagonal matrix of a lower triangular matrix equal to 1, and then we multiply L and U and compare with the matrix A and find the values of unknown of a lower triangular matrix and upper triangular matrix. Once we find the values of a lower triangular matrix and upper triangular matrix, then we write a given set of a system of a equation in a matrix form. We put A equal LU, then we assume that UX equal Z, then LZ equal V. We solve the LZ equal V in order to find out the values of a Z. Once we find the values of a Z, then put the values of a Z in a UX equal to Z, then we find the values of a unknowns.